All right, so now I'm going to talk to you about the parallel plate capacitor, which is a really common setup. It's an important setup. So it's two conducting plates with the same magnitude and opposite signs of charge. So you can see on the left we've got a plus Q, on the right we've got a negative Q. And just to make it super clear what we're looking at here, these are plates. Here's like some perspective because I'm such an amazing artist. Okay. So, generally most of the math that we do with it are, we treat them like infinite plates. And again, that just means that they are close enough together so that this distance between them is much, much, much smaller than any of the linear dimensions of the plate, which I labeled here L. So this has a bunch of different really, really important results that we will just keep coming back to over and over. I think that maybe you guys saw a video, or I showed you, or I said something, and I told you that the electric field inside was that, and outside of the plates it was 0. So I just want to prove that to you real quick. So when we talk about these parallel plates and we talk about them having a total charge Q, we can also equally discuss the surface charge density sigma, of course. So let's just start by looking at the left-hand plate. So it has a charge density of positive sigma, and its electric field is going to look like this way, and it's a very thin conducting plate. So it's right. We're not zooming in on a surface and looking at inside the conductor. It's very, very thin, and so on this left-hand side, we will have a value of sigma over 2 epsilon naught, and over here we will also have sigma over 2 epsilon naught. So I think one of the previous videos, we had this happened to be a insulating sheet of charge, but when it's a thin sheet of charge, it doesn't actually matter if it's insulating or conducting, because we're just looking outside. And so we proved that sigma over 2 epsilon naught is the magnitude of that electric field. Okay, so now let's look at this other plate, and that's going to have a field that looks like this in, and that is also going to have a magnitude of sigma over 2 epsilon naught. So hopefully you can see if I move, oh gosh, that's nifty. If I move these close to each other, hopefully you will see, oh my gosh, this is so cute, that, let me get a different color for the vector sum. We have a sigma over 2 epsilon naught plus a sigma over 2 epsilon naught, which is going to be sigma over epsilon naught. And here we have this and this. So that goes away. And here we have this and that. So again, inside, so plus Q minus Q, or plus sigma minus sigma, don't matter me none. Inside is sigma over epsilon naught, and outside is 0. Okay? This is a very important thing we will come back to lots and lots. But before I leave you, people often get confused. And, I won't lie, sometimes I do too. We have, so sometimes you saw E equals sigma over 2 epsilon naught and sigma over epsilon naught. And these are sort of things that happen in general So we've had, if you look back at this packet, you've had these answers to 2 different problems. So it's nice if I can actually summarize where you see these. E equals sigma over epsilon naught is, we just saw, in between plates of parallel plate capacitor. Okay. You also saw it on one of the previous problems that it is the electric field near the surface of a conductor. So it doesn't even matter what surface. It could be, it could be a sphere, but if you look right near the surface, you will see that the electric field is perpendicular and it has a value of sigma over epsilon naught. And you can actually, there's a cute little calculation that you can do. We did a conducting sphere, and you saw that outside it looked like kq over r squared, right? And we can write that as E is q over 4 pi epsilon naught r squared. Well, if you actually evaluated it at the radius r, it's q over 4 pi epsilon naught capital R squared. Well, looky there, people. Q over 4 pi r squared times 1 over epsilon naught. That's how you could rewrite that. Q over 4 pi r squared is sigma. So sorry, I'm running out of room and that's so ugly, but it's quite a cute little thing. Okay, so that's where you're going to see sigma over epsilon naught. Sigma over 2 epsilon naught was the electric field from a charge sheet. Okay, from a charged sheet. All right, hopefully that helps.